So that would work. I mean, I could definitely make this work by holding the IDs of my products in this text column. But I might have, if you think about it, if you're Amazon, yeah, you could have like millions of customers. Each customers could have, hundreds to thousands of orders. So that's like all of those arrays that you have to serialize. You have to go search through them. That's going to be a little bit messy. So a better way to think about this would be as an associate, like the association between order and products. And just kind of think about this not in database land, but like, does a order have many products? Does a product have many orders? Like, does it belong to, like, kind of someone say that to me, like using those kind of that terminology.
An order consists of many products.
Yeah, but can a product can also have a product could also have many orders. So this is a this is a many to many, because a product can belong to multiple orders and an order can belong to multiple, and an order can have multiple products. So I think when you're thinking about those relationships, I like the Facebook example or the Twitter example, where I'm a user, and if I create a post, like that post is just going to belong to me and me only. But a product could belong to many different orders. And a order can have many products. So this would be like a has many through association, or a many to many. And then this I could call like my products or product orders. And so this would have the product ID, and it would also have the order ID. And this is our foreign key. And also let me throw this inside of here. This would have a customer ID, which would be the foreign key. So a customer has many orders. An order just belongs to one customer, right? It wouldn't really make, I mean, we could probably create a system where an order could maybe belong to potential different customers, like people could share an order, but that's usually not how that works. But here with this product orders table, this is telling me, hey, this is the product. Let's say it's, I don't know, gum. And it was on order 1, which, I on this date, like James bought gum on July 1st. There's one thing that's kind of just with this demo, and it's more with the product and product orders. So I kind of want you to think about this price information. And I think because this might help you make the distinction of like, what is this table actually doing? Because I mean, we could leave this table like this, and that's fine, because this is what's called a join table. It's joining two tables. It's having the two IDs, the two foreign keys of our tables we're joining. Now, a product has a price, but I kind of wanted you to think about this price thing here. maybe it should just be called something different, and maybe there should be another price field here. Because let me ask you this, is a price of a price of a product, is that always consistent? You could have a thing like a sell, right? Or like a discount, or like a whatever, like a special code where you get 10% off. So how might we, where would we want to put the price, and maybe what should this price be called?
So you can call that one like MSRP.
Is the MSRP, yeah, what does the MS stand for?
Manufacturer suggested retail price.
Yeah. I was going to say retail price, so, but yeah, MSRP. So this is like the retail price. This is like how much, yeah, the manufacturer says, hey, this should be sold for this much. But then on your product's order, this is actually like the sold price, or what's the right term for that? Does anyone know? Sales price, sold price. So this would be like the actual amount that was charged for the order. Does that make sense? Does that kind of help explain what the product table is doing and what the product order table is doing? The product table is like this blueprint for describing one product. So, maybe a good field to go here would be like a description about your product.
So can the product orders, like they have many products? Or are we just doing one, like order one thing at a time?
So would you repeat that?
I'm just thinking, are we gonna make the like person be able to order multiple products at once in one order?
Yeah. So yeah, because a customer is going to have many orders, but those, how I would say that is that order has many products through this table. So if we were to actually, I think this can be useful to like, pretend like we have a database. So let's say I have like I have some data in my database. So here's my products. I have like a name and MSRP. So my products, I would have a name. Actually, let me get a different table. Let's get one with 3 columns. So here's my products table. Like, let's just say this is like my actual data inside of here. So it would have an ID, it would have a name, and MSRP. So I would have like, that would have an ID of 1, have an ID of 2, maybe the name is gum, $1.99, and then I'd have like a, I don't know, soda. Let's do a knife. Nice fancy knife. Okay. So there's my products. Then, I could have let's do a couple users. So I have a user, that would be an ID. I'm just going to make up some IDs here. So Bob. That's good enough for now. Could have a order. Data, so this could be our ID, this could be our customer ID, and this could be our date. Add column. Add. Does anyone see where? It's row below. Okay. Okay, so I have some orders in my fake database. I have some products. And then I would have some product orders. I'm done. It's not letting me add anymore. Let's see here. I need to delete the table. So I need one more. All right. Just a little side note, Lucid's based in Salt Lake, and I feel there's like about 4 or 5 people from DPL that work there. So I know there was like one student I had like a year ago. She got a job there, and then she just like went on like hardcore recruiting, and she got like 4 or 5 people from DPL to work there. So yeah, it'd be a place I'd recommend to like apply for. It seems like they like hiring some of our folks. Okay. So we have customer ID, and then we have a, well, let's do our sold price. You can see it. Sorry, it would not be a customer ID, it'd be an order ID. Messed up. And let's do one more. So let's say I'm just looking at this one row right here, this one entry. Who bought this and what did they buy? If you're just looking at this column, and then you can go like look at your other tables as well.
It looks like John bought the first one, probably.
Yeah, because the order ID is 345. If I go to my order table, the order 345 has a customer ID of 23. Well, that ID is John. And then the product ID is 1. There's my gum. I also have a order ID of 345, which is with the product ID of 2, which is my knife. And that's also John. So it looks like John on 1/12/21 bought a gum and a knife on that same order. For 50 cents for the gum and $100 for the knife. So it looks like he got a deal on those two things. Then I have another order, product ID 1. So that's the gum. The order ID is 343. So once again, that's John, but that's a different date. So this is a different order, buying gum on the 10th of January. And then I have another one with this order ID 234234. Well, if I look at my order data, looks like that's customer 34, which is Bob. Bob on January 10th bought some gum for 55 cents. So here's how your database, this is like the blueprint, this is how it looks, that's the order. But when you actually store data in here, this is how you're going to store the data in here. But then for these join tables, we definitely need to keep track of the ID. That's also the other important thing with like a has many. So our order belongs to a user. So we're definitely going to want I say customer, I'm kind of using, but like that should be, so I should make this like user ID just to make that match. But does seeing it like this, does that kind of help like explain like, here's how we think about it and here's like our schema, but when we store our database and when we're interacting with our database, we're really just, keeping track of like these IDs. My products, I only want to have like all of this gum information in my products once. And then if I ever want to like access that information in other tables, I can, but I'm just going to keep track of the ID. Does this kind of help to like visualize it like this? And like here's a pretty straightforward database design, but with this database design, you can make a pretty functional app just with these 4 tables. Because you can have some customers, you can have some order information, product orders, that kind of thing. Let's think about maybe like adding an address. It's kind of a little interesting. So it might make sense to throw the address stuff on this customer table, right? Insert row below. So let's just do like street. We'll just keep it simple, street. And city. Those could be strings. So that could maybe make sense though, right? To throw that on the customer field. What But can anyone maybe think like why maybe we wouldn't want to do it this way?
A lot of people have multiple shipping addresses, and addresses could belong to multiple customers if there's like roommate situations and things like that.
Yeah, so this would work if like if we're kind of thinking our customer is only going to have like one address. But yeah, it's not unlikely that our customer, especially if it's like, something like Amazon, they could have multiple shipping addresses. So the downside of doing it that way is if they have multiple shipping addresses, let's just throw in like address here. I would need to come in here and like, if I want to add another address, if that's how my database is set up, I need to come in and throw in another entry for like John. And then that's just going to be bad. Because now I have the same person in here twice because I'm trying to keep track of like their two different addresses. So that's like definitely not good.
The same way that you had like a product have a price, but then you had like a sales price on it. Couldn't you have like a user have an address, but then have the address they actually sent it to? Because maybe I want to buy my girlfriend a gift and I send it to her house. That's how I would approach it.
Well, I could have one, because if this is like Amazon, I'm just kind of thinking like, this is really just a shipping address. And I can, because on Amazon, I can say like, maybe I want to have like a default address. Is that kind of what you're thinking about?
Yeah, the way that, if you were to go to Amazon and it would say, do you want to send this to this address or do you want to use another address?
Yeah, so that like,
I don't want that other address to like become my main, like my address.
yeah. So what I would do is this, because if I'm thinking I'm going to have multiple addresses, shipping addresses, then yeah, I would definitely break this off into another table. I'm going to delete one of these. Let's go delete it from here. Okay, so I could come in here and then yeah, I'm going to add another table. So a customer now has many shipping addresses or addresses. And then, here I can throw in like the state, like the street and city. But I could also throw in something like, primary, and that could be like a Boolean. So it could have, you can have multiple addresses, but maybe on one, there's like a primary Boolean. So like, hey, this is my primary address. And this would also have, why did I call that customer? Anyway, customer ID, which is my foreign key. Doesn't like that. Is it really keeping track of these things? That's crazy.
And I think that kind of does remind me of how it looks on Amazon, because you'll have like a whole set of addresses as like a link if you were to go to your profile.
Yeah.
And then same thing with like different cards and stuff. So that makes sense to me.
Yeah, and that's like another, like we could add cards and then maybe a card, like a payment or a payment method. Maybe on the payment method, even then I'd probably break that up into like it has one, like a payment method has one billing address. I don't think billing address, like a payment method, you can have more than one billing address on like a credit card. I don't know if that's something is that true? Any bank people here? So
Payment method should only have one billing address.
yeah, but even then, like, so we do have the has one association. I might want to keep, let's look at that example because that's a little interesting too. Actually, I'm just going to get rid of these tables here. So yeah, now I might have like a payment. Let's just come down. So this is my customer. I'm going through my customer. A customer is going to have, you know, a payment or like a payment method or whatever. I don't know, a card. Let's just say credit card or something. So a customer could have many credit cards, you know, that's going to have like a credit card number. Encrypted card number. So another thing you might want to think about when like you're talking about database stuff is like encrypting certain things. So if I'm storing any credit card information, like a number, I would definitely want to encrypt that. So what that means is the user is going to enter their credit card. I might store that in my database, but I'm not going to actually store their credit card number in my database. I'm going to like encrypt it and then store that encrypted number on my database. That way, if my website gets hacked in some way, I don't have a whole bunch of like credit card numbers and like, you know, whatever the CV2 numbers. I'm going to like encrypt all of that stuff.
I don't want to get too off topic, but that is something that I thought about the other day and I kind of wanted to ask you, which is as like a developer for a company, what's your like level of liability for your code? Like let's say a backend person did accidentally make a way to view like other credit cards. Like, is that person like legally got any like liability for that mistake?
Ooh.
You know, I'm always hearing about like data leaks and stuff, and I'm wondering if there's anyone like taking the fall for those.
I don't know at what level. I know people you can get like, have you heard of anyone like getting arrested?
I mean, you would think it would be the hacker that would be the most liable in that case, but
Yeah, I think you have to be like pretty negligent. Like it's definitely, you might get fired for like, if it's not negligent or if it's intentional, you'll probably like, if you intentionally put some code in there so it's easily hackable, yeah, I'm sure they would go after you. But if it's just like you made a mistake and someone hacked you, can't really be, you know, responsible for that. It's like, I don't think the people who coded, you know, the like the Max Boeing 737 Max, because that's like a software bug. It's like they're probably not going to go to prison for that, even though, you know, hundreds of people died, because it was like just an honest mistake. You might have some people get fired for that, but that's going to be like, it's probably going to be like the more high level people. But if you're a coder and like you wrote some really bad code that made your website easily to hack, you might just get fired. I would say that's you're probably not going to get legally in trouble. And then it might not even be you, it'd probably be like your supervisor, because kind of at the end of the day, it's like, it's kind of like the product owner's responsibility. So, cool. So yeah, then we could have like this credit card information, but then a credit card, you know, could have, damn you, it's not letting me do this. I need to like, I have too many things. It's like limiting the amount of things I can draw on here. So a credit card could have, there's a way to switch this. Here's like the sign for one. A credit card could have one billing address. And, you know, I think with the has one, it's like I could throw all the billing address information on this because it's not going to have multiple, but sometimes, you know, it just can be, you know, separate. This is my credit card information. And that's like the ad, like they're kind of two different things, even though they are associated. So there's our little database structure for Amazon. So a customer has many credit cards, a customer has many orders, a customer has many shipping addresses. An order has many products and a product has many orders. So that's a many to many. That's through our product orders table. So that's kind of like the process. So let's just kind of just briefly go over these just to like reiterate these types of relationships and what they are. So there's the one-to-many relationship. And in this example, we have quite a few one-to-manys. So we have our customer has many shipping addresses. This is a one-to-many. I could potentially make this a has many or a many to many, but the way I'm setting this up, my customer has one shipping address and that shipping address belongs to a customer. And that's probably how you, even though you might have a customer that lives like, so, you know, say there's a husband and a wife and they live and have the same shipping address. I would probably still like, because you can think about it in the real world, you know, husband, wife, they have the same shipping address. But I probably, or and Amazon probably does this, it's probably just a one-to-many. Because when you think about Amazon, it's not like, I don't know, can you have a shared account in Amazon? It's like your account is your account, right? When you log into Amazon, you're logging into like your account and you have one address. I don't know, maybe there's a feature in Amazon where like you can have a shared account with someone else and you have that same address. But with Amazon, like I'm one or I could just say with this app that we're building, I'm planning on not having that feature. I just want to be able to log into my website, buy some stuff, and ship it to my address. A customer has many orders, but an order is going to belong to one customer. That's the one-to-many relationship. And just kind of looking at this, another way you could think about this is like a a presidential candidate and a political party. So you could have like Republicans and Democrats. There's your two political parties. But you could have a political party could have many presidential candidates. But every presidential candidate's going to belong to just one party. So that's the key there. Just the thing belongs to just one. So we have a many-to-many relationship. And we can see the many-to-many relationship. An example of that is with our product orders table, or like our products and orders. Because our order can have many products, but our product can belong to many orders. So that's the many-to-many relationship. And anytime you have a many-to-many relationship, you're going to have this join table. And these can we're probably like, if we get into like this address, well, I'm not even talking about that. I think there's something we could probably add like a address ID to this order table. And then that's almost probably going to be another join table. No, wait, sorry. Let's just do that really quick. Think about that just to kind of stretch our thinking. So now that we have an order and a customer has many shipping addresses, how do you think that association would work between order and shipping addresses?
It's probably going to be a one-to-one, and order has one shipping address.
Yeah. So that would be a one-to-one. And then I could just inside of here, my order has a shipping address ID. Here's actually a really good example of where you would want to act. I think sometimes the one-to-one you can sometimes think, well, why do I want to like throw that into another table? I think here's definitely a case where it's nice, obviously, to have this, your shipping address is already in another table because our customer can have many shipping addresses. So although our order only has one shipping address, we don't want to keep all that shipping address information in our order ID. Let's just I want to talk about, what did we talk about? All of our association. So there's our many-to-many. We have a student has many courses and a courses has many students. And when we talked about that example, that was like our join table. So they're always going to have this join table. You can have more than 2 tables. You could have like 3 tables, like joined together, 3 plus, 2 plus. You definitely need 2. But the thing with the join table, it's going to keep track of the IDs. So a student would have many courses, a courses would have many students. And we could say this is through like an enrollments table. So I'd keep track of the ID of the student, that would give me all the student information. And then the ID of the course, that would give me all the information about that course that student's enrolled in. Okay. I just want to talk, since this kind of came up, I just want to talk about this one example right here with the shipping address ID. Because the way we have this, I think this is a good way to do this. Like this would be the preferred way to have a customer have many shipping addresses. And then throwing the order here has one shipping address. This is the better way to do it, but I'm going to show something. I'm kind of going to delete some of these tables so I can do another example. Because another way you might think about doing this is, why don't I just have the order have the street and the city, instead of throwing this in this own column. Right, so I can do something like this. So now my order has the information of the street and city. So I technically don't need this shipping address anymore because it's now inside of here. And this would work. This would have all your information because we still have that same information. I maybe could even throw in right here, I don't know, a primary Boolean. That kind of makes less sense though here. So the reason why this might not be ideal, because an address, first of all, an address has way more than just a street and city, right? It has a street, city, a zip, country, mailing address. So it has a lot more information. With this way, if I'm James and I'm ordering stuff, I'm going to be duplicating all of this street and city information in my database. Because every time I make an order, I'm going to go into my database. So we could look at an order. You know, it'd have the street, city. Let's say I only have like 2 shipping addresses, or even just 1. Every time I come in and create an address, it's going to save my address and state in there every time. So if I have 1,000 orders, and it's all the same shipping address, this 123 Maywood and SLCs is going to be in my database 1,000 times with the same zip, you know, same country, et cetera, et cetera. So that's going to be in there for every order, even though it's the same information. If I have this on a separate table where I'm storing, you know, that information, then what I would do is I just have the address ID. And then in my database, all I'm storing is that ID. So it's going to save a ton of space. So then if I want to get like, you know, this city, state, and zip for address ID, I just need to look at that entry that's going to be in this table, and it'll only be there once. Does that kind of make sense? So, and that's a little more detailed with our database design. A lot of the things, one of the things you want to try to do is you want to try to get rid of throwing duplicate data in your database. So if I'm James and I have the address 123 Maywood, you know, I should try to figure out a way to design my database so I only store that in my database once. And if I have my order like this, where I'm keeping track of the street and city, I'm going to have to like duplicate that data. But if I just have the, shipping address ID, then I'm only going to see that. I mean, that address ID is going to be in this table multiple times, but that's fine because it's just the number. That's very light storage, or very small. So, cool. There's a little more about designing databases. And yeah, so I think today you'll definitely, this is kind of one of the things you'll be doing today is just going through and trying to draw out your database diagram. But can you, I mean, can you see just with this diagram, this gives us a pretty good roadmap to what we're building, right? And it's kind of made us think about some things about like, how we're going to design this app. So this would be like a pretty decent starting point for like a simplified Amazon. So I think and like I said, once we have the associations, I think it's a little easier to go in and then like, maybe we want more than just a first name and last name for customer. Should probably have like an email, maybe an age, gender, I don't know, other things. So cool. Any questions with this? Sweet. If there's no questions, let's take a break. Let's come back at 11:50. And then we'll talk a little more about Trello and some product management type stuff. And then, yeah, we'll take lunch. let's go ahead, get started. So just for the rest of the class, we're going to talk about some project management stuff. Nee's also going to be giving a presentation on this, but let's talk a little more about it, because we are going to be using it from here on out, Trello. It definitely is becoming more important since we're doing a little more longer term stuff with, with a big group. So yeah, because up to this point, we've pretty much been working on homework that's maybe, 1 day, 2 days, maybe even 5 days. And there's either 1 or 2 of you working on it. So, and yeah, that's great for learning. It's obviously you just can learn a new concept, build out an app, and just kind of delete it. But you're going to kind of get your first taste of like, this portfolio project's kind of like your first taste of maybe like working on a real world project, where it's not just going to be a day or 2, it's going to be, about a month. And you're going to be working with, 4-ish developers. You might have like Will's going to kind of take the role of like your designer. Me and Michael are going to take the role of like a project manager. So you're kind of going to get a little taste of that. So yeah, with this and, some things that are going to start changing, especially when you get to like a real company, is, the projects that you work on, they're going to likely have been around for months, if not years. I've worked on projects that were like, 5 years old, that have just gone through like iteration of iteration. So, and, they're kind of planned out like indefinitely. So, I mean, think of an app like Facebook. Like if you were to go work at Facebook, Facebook's been around for what, I don't know, 18 years. Actually, I have no clue, but it's been around for over 10 years. And it's probably going to be around in, 30 years. So, when you're talking about, an app of that like length of time, really, how do you organize, the process of something that has been around for years? How do you plan for things like bugs, new features, new features that we don't even know are going to exist? I'm sure when Facebook started up, 10 years ago, they probably weren't, maybe they didn't have in mind like how much they would like influence elections. Maybe they did, but that might have not been like, on top of their minds when they, like the first year they were building out the app. So there's going to be new problems, there's going to be new opportunities, that kind of thing. Another thing that's going to change for you when you kind of get to a job is you're going to be getting paid. I mean, that's probably the biggest reason you're here, is to get the money. So yeah, and with this paycheck, it's probably more likely that the client or your boss is going to want to be able to see at some level, what you're working on. They're going to want a roadmap, estimations. They're going to want like, how long is this going to take? How much is this going to cost? Just with how much software developers make, software, you can just see how like software is a very expensive thing. If you want to go build out an app, a website, it's probably going to be very expensive just because you're having to pay engineers to build it out. So if you have a feature that's going to take, 5 developers 4 months to build, you're talking, hundreds of thousands of dollars to build that feature. So we're talking about like a lot of money here. So people who are paying that money, they're going to want to see what's being worked on, how that's, being utilized, and they kind of want to guess, how much is this going to cost? How long is it going to take? So we're going to start needing tools for that. So another thing that's you're going to kind of, so there's going to be kind of that like maybe pressure, or that, kind of people wanting to know what's being worked on because it's costing money. Another thing that's going to change when you get to like a company is you're going to have many teammates. And you also might have you might be working on many projects. That's been what it was like for me. I was always working like at like Teleperformance. There was like 4 different projects that I worked on. At Evernym, there was like 3. So they kind of like pulled me off and kind of threw me where they needed me at any given time. So not only are you working with many different teammates, and also your teammates, with both companies, I've worked with people in like different countries, in India, where they're on like, 12 hours opposite your time zone. We've had teams with like, a team where we had people in India, Russia, Serbia, just all over Washington State, Salt Lake. So you're going to be working with many teammates. They might be in many different places in the world and different time zones, different projects, all at just one company. So once again, there's this need for organization. There's this need for product management. And then finally, or another thing, software is just really complicated. It's very much a thing that is always changing. Technology changes. There's always bugs that are coming up. You're always going to run into these issues. It's like one of the things that really like surprised me is how often the requirements changed. Because I'd be working on a feature with like, 4 or 5 other people for like a month. And then you'd have your boss just come in and say, hey, scrap that. We need to do something else. It's like crazy because it's like so much money just spent on that. And you're just going to like scrap it just to move on something else. But it happened, like, it was my experience where that kind of happened quite a bit.
Cheaper than buying a building.
Yeah. Very much cheaper. And also, I should say like this, that can maybe be part of teleperformance. So I think I had like a pretty good experience with teleperformance and Evernym, because teleperformance is like this established call center, it's $1 billion corporation, it's been around for years. And they just pretty much, so they had kind of all this money where they could, because they had like an in-house development team that was building products just for teleperformance. And, they had tons of money to build those products. And they kind of knew what they wanted because they were building it for themselves. So the requirements were a little more clear up front. Those changed less because they knew what they wanted, because they were like paying themselves to do it. Evernym, on the other hand, was like, this startup company trying to create this new technology of digital identity on the blockchain. And so just, who was always short on cash, like maybe had 3-4 months of runway, before they were going to go like completely dry on cash. So they were just always like changing what they were trying to do, because they had that short-term vision of just like, well, how do we get funding for like the next 6 months? So that was a little interesting to kind of see those 2 different perspectives. So that can kind of be something when you're thinking about what kind of job do you want to work at. Do you want like a nice, like, teleperformance was definitely a lot more stable. Like they definitely had, like, there was no money issues with them. They're just a huge corporation. But their feature set was kind of boring. Like Evernym was like trying to like build something new, so it was like fun. They're always using like the newest technologies, but it was a little stressful. Like my first 2 months there, they like laid off 40% of their staff. So that's like a fun first 2 months. Anyway, but regardless, they, you know, this is software is so complex. It's so much like, there's so much that goes into it. And it's really just, I mean, like part of my French, but it's just kind of like a clusterfuck. Like it is, I don't know. It's just a lot going on. And yeah, so what we need is some product management, some way to manage this complexity, this mess, because it is messy. So there's kind of these two basic ideas of management that you'll kind of hear talked about. There's the waterfall cycle and the agile method. So the waterfall method is like this old school, like 1960s way of doing things. It's very, you can think of it like very governmental, very bureaucratic, where when you do something, you follow this process of, the first thing would be like, you get all the requirements up front. Before you start building anything, you get like all the stuff you need. You get all the requirements, all the use cases. So there's a whole bunch of planning involved, tons and tons of planning. And you don't move on until you have all the requirements. Then once you do have all the requirements, then you go to the design phase. So that's, you're kind of maybe designing your lucid chart. Like what's your database going to look like? What's your software architecture going to look like? You're going to meet with like the stakeholders, see what they want. So it's just kind of like you're designing the blueprints of it. So then once you have the blueprints, then you go and you actually go build it. Implementation, you go construct the software, the databases, all of that stuff. Then the next step would be like your verification. You install, like you just kind of test it and debug it, hit it with a hammer, that kind of thing. And then you have your last phase of just maintenance, because you got all of the requirements up front. So now you're just maintaining it. Now the waterfall methodology, you would probably want to use this with something like building a building. Like if you're going to go build a skyscraper, you probably want to get all the requirements up front. You're probably going to want to get all the blueprints done right before you start building it. Like you're going to want to make sure, like, you know, the ground you're digging into is solid. You know, you do all that studying. You're going to want to have all your designs built out before you start building a building. You'd probably be really dumb to like go try to build a skyscraper if you don't have like the blueprints. So it's not like, so the waterfall methodology is a very effective way to do stuff, to build things. But it doesn't work out so well with the software world. So what the software, like, and you know, there are actually some places, some software companies, or I don't know who uses it, but who might use the waterfall methodology. This might be if you're like designing software for like NASA. It might work out good if you're like trying to do like rocket ship software. But if we think about something like Facebook, first of all, how is Facebook going to know all of their requirements? Right? How is Facebook going to know in like 10 years they should like, oh, we should develop a thing called Meta, and it should be the metaverse where it's all virtual reality? Like, so that's part of the problem with the like in software. If we think about software, software just changes so quick. What people want changes. It's not like a building. like a skyscraper where it's like in 20 years, you think you're gonna like, I don't know, turn it into a rocket ship. Like a building's going to be a building. But think about something like Google or Facebook. Google just started off as like a search implementation website. But then Google's like, oh, you know what we can do? We can add YouTube to this. We can add maps. We can add a self-driving car company. We can add AI to all this crap. We can add a Gmail account. So software is meant to just, you know, be kind of a little more dynamic. So, and back in the day, like this was the method that they tried to use to manage software, but there's kind of the more common one, the more popular one that came out, and that's called Agile Development. So the way I like to think about Agile Development, it's kind of like if you were to take the Waterfall development method and just like put it in a loop, where you're doing it in small incremental cycles. So what you'll have these loops called is they're generally called like sprints. And and so Agile is kind of like the higher arcing term. That under Agile, you can have a type of Agile that's called Scrum. Has anyone heard the term Scrum, like a Scrum meeting? So what you might do in an Agile workflow is you would do something like a sprint planning. So you'd have a sprint, and a sprint is just kind of like a certain amount of time where you're going to get some work done. Sprints can be like a week, they can be 2 weeks, they can be a month-long sprint. You just kind of like take up a certain amount of time and you say, hey, we're going to do this. Like Teleperformance, we did month sprints. At Evernym, we did 2-week sprints. So what you do at a sprint is you do some planning, and you can kind of think of the planning as like maybe partly like these two phases where you're getting requirements and you're doing some designing. It's mainly like the requirement phase of this waterfall. So you're going to grab your requirements. You're going to decide, hey, what are we going to do the next month? And then with the Scrum, you're going to do a daily Scrum. We're going to start doing this week, where you meet with your team daily and you talk about what you're working on and what you're going to be working on that day. And then you kind of go through and you plan out what you want to build in a backlog. And then for that month, you do daily stand-ups and you kind of go through and you go work on that backlog. Now there's always, even in the monthly sprint, you can always refine this backlog. Like what tasks are you working on? And you do these small incremental changes. And then at the end of the month, you do like your little review. So that's kind of like your verification. So for the month, you're implementing your features. And then at the end, you're going to like verify, and then you're going to be done with your sprint. And then you start over. So the Agile method kind of just puts this in a loop where you're not trying to grab all of your requirements up front. You're just trying to grab all your requirements for that next chunk of time. And then within like the sprint, like the maintenance is just always a part of software. You're always maintaining it, always debugging it. So that's Scrum. There's other kinds of Agile development. There's the Kanban board. So the Kanban board is just a way to just see a nice little list of like, you have stories, you have stuff you're going to do. This would maybe be your backlog. You have tickets you're working on. You have tickets that might be in testing, and you have tickets that might be done. So there's different setups, and this is what we're going to use. We're going to use, it's kind of like a combination of Scrum and Kanban, because the Trello website is just a Kanban board. This is what this is called. It's a Kanban board. So we might, when Will says, hey, we're going to do weekly design meetings, you can almost kind of think of that as like our sprint planning. You know, we might have like week sprints. What are we going to get done this week? So we'll meet up with like Will and kind of talk about, you know, what we can do for that week, what the design's going to look like. And then you'll meet up with either me or your TA or Michael. We'll do daily scrums. What are you going to work on for that day? But then we're going to use a Kanban board to manage that. So yeah, these all have advantages and disadvantages. I think the Kanban, like the biggest advantage with this is it just gives you this nice visual organization of where everyone's at, what you're working on, what things are coming up next, what's done, who's working on what. And it also creates this place where, you know, this kind of one source where you have references to everything. Yeah, so I would say let's look at some disadvantages and just disadvantages with product management. You know, you can get into like over planning, where you like over plan things. You're maybe spending too much time thinking about what you're going to be building and what you're not going to be building, and instead of just coding it. Another disadvantage of just agile development is sometimes, you know, you maybe don't upfront think about these requirements. You don't spend enough time actually thinking about what you really need. And like I said, there's been so many times where just work on something for a month and then they just throw it away or like put it on the back shelf. It's just, okay, we just wasted a month on that feature. That's, you know, I think you can kind of get into, you're a little too flexible and you pivot too much. Because then you're just building a whole bunch of features that you're not using. But it's hard. I mean, it's more just, it's the solid, like, especially if you're in a startup, you know, it's just things are changing and you're just trying to survive. So yeah, and it just becomes, this board becomes something you have to maintain. So generally that can be a full-time job, maintaining a product. Cool. So yeah, this one's just kind of a little silly thing to like look at. Agile development, because, you know, people talk about how cool, you know, product management is, but there's kind of like when they talk about it, it's like, oh, it's so awesome. But then in reality, you know, you have your waterfall method where you get all the design up front. And this is so true when it's like what the client wants. They want a nice car. And then when they think about how much it's going to cost, it's like, that's what they get. I don't think a lot of people don't understand how expensive software is. So, but one of the problems with the waterfall process is, you know, you might have a testing guy who's just sitting there waiting for all of this stuff to finish because it's kind of this flow. So what is this guy doing while, you know, you're designing it? So, then you have the agile development, which is just, you know, small incremental changes. So you're designing a car, you know, you start out with like a crappy, you know, air mill and then eventually put it on. And yeah, the client is involved in the process, or more, I should say more involved, which is a good and bad thing. So then you have the client like telling you what they want, but that's got its pros and cons. Kanban always got, it's funny because like when you show these like agile cars, like it's kind of like, you know, this whole process, these cars are so incomplete because you're just trying to do the MVP. And that's the other term I wanted to look at here is the MVP. We'll kind of look at that because that's really going to be the goal of these, your apps, is we want to get these to a state of MVP, which is like the minimal viable product. So like if you're designing a car and you wanted to like get the minimal viable product, you know, it should have some wheels, a seat, and a steering wheel. You're not really worried about maybe air conditioning or like electric windows. You're just trying to get that minimal thing that actually can do the functionality that you want it to. So, and something just to also like state before you get started, you're gonna think you have 4 weeks it's like kind of like 3.5 technically to work on this product. It's going to fly by. And so really think about what features that you have to get done and just bust those out. And if you do have time, then focus on those features that are nice to have. Because you're probably going to start to see, and I think every group, and I don't know, I think this is just maybe human nature or just like in the software world. I think it's easy to overestimate what you can get done. So when we're talking about our portfolio project, and I have this just as a link, I kind of want you can use this, but here's kind of, and we've talked about this a lot before, but here's one of the flows you could use. You don't have to use this. How I would break this up into like a Trello board is these columns or these columns. So you could have like resources, tutorials, just like a miscellaneous column where you can kind of throw links, maybe some tutorials. You could have some stories. Now think about a story. A story is just going to be more where you can write about like what, like kind of how you want your app to work, or like what features you can describe your features just in English. Like, for example, if I was doing like a story for Gmail, I'm sure once upon a time, you know, they had a story that was like, get rid of spam. And like the story probably went something like this, like we want to use AI to eliminate spam from email. And like, you know, if user still receives spam, as spam, this will help train, you know, our AI algorithm. So in the future, it will catch similar email. So this is a story, like, right? I spelled all this stuff horribly. But here's like a feature, I mean, that I could maybe describe in two, it's probably it would be a lot more detailed, but even with just like these 2 sentences, hey, I want this feature where we're going to use AI to go through and sift through our email and like eliminate spam. And we're actually going to have the user of Gmail to help us mark spam. So we're going to have a feature where, you know, a user can mark something as spam, and that's going to help our AI realize that was spam. So in the future, they don't get a similar email. Now that kind of explains the feature, what we want. That's the story. Now that, as far as like a ticket, this is not really a good ticket to say like, hey, George, go work on this story. Because that's a huge story, right? like this needs to get like broken down into like hundreds of subtasks. Like someone needs to add a button on the email to like report spam. So there's like a front end story of like, hey, let's add a button on the front end so someone can report spam. And then there'd be another ticket of like, hey, let's save that to a database or something. And then there'd be another ticket of like, hey, let's go through that and like send that to our database, and then cool. Then there'd be another ticket of like, well, someone needs to write the machine learning program to like go through all your spam emails and figure out what makes them spam. And that's probably its own little story in of itself. So, and I'd say for this app, maybe you don't need to do the stories. I just kind of wanted to show it because the stories are going to help you. And another way you could kind of think of this as stories, or you could also just call this like features. Because once you get your stories and features, then you can start creating those specific tickets of like, adding, UI button to report spam. Now we've actually created a ticket. Now this is a little more easy to say, hey, George, go add a button to report spam in Gmail. So we can take this huge story and break it up into actual doable tasks. All right. So just to make the distinction between the backlog and on deck, they kind of seem like they're the same thing. The reason why you might have, and this is what we had at Evernym, we did have like kind of these two separate columns. We had a backlog and a on deck. The backlog was there just so we could throw any feature that we knew we wanted to do at any given time. It's kind of like once we knew we needed to build something and we kind of knew the requirements for that feature or for that task, we could throw it in the backlog. But it wasn't necessarily pressing that we got it done. The on deck is there to be like, okay, these are the next features we want to start working on. So we had like actually size restrictions on how many tickets could be in each column. So for instance, our backlog could be as big as we wanted. There could be like there was literally like over like 300 tickets in our backlog. But on our on deck, we had like a size, there could only be like, 6 tickets on deck at any given time. So it's just there to like kind of force the prioritization of what to work on next. It's like, here are the next 6 things we need to get done. And so then that way, when a developer got done with a ticket, they could go to on deck and, they could kind of just pick anyone they thought that worked out well for them. So they could then pick something on deck and then put it on the in progress. And then start working on it. Then there's going to be a QA review that we're going to have. So the QA reviews, this is where you're going to do your pull request. We kind of showed this last week. So if we're kind of going through the flow of this, you would have a story. So let's say we have this story of get rid of spam. And then from there, we would take that story and break it up into smaller actual doable tasks and throw those in the backlog. And then once a task was like ready to start to get like where we thought it was like a priority to work on it, we would throw that on deck. And then once actually you had a developer ready to work on it, then that goes in progress. And this board kind of has some instructions for like, you know, why we're, before you move something, you should kind of finish this up. For example, like the pre-on deck instructions. This is a place to put cards when they are ready to be worked on. The project should be in a state where any pre-requirements for the card are complete and changes are in master, or there's good reason to begin working on it. So really, before you move a card onto here, it's kind of like I said, it's good to go. And you know what you're working on. When you move to in progress, you know, card should be placed here when that card is being worked on. Before moving a card to in progress, make sure the requirements are clear, add your name to the card, pull from master, and create a new branch. So when you start working on something, you know, we do this, we make sure the requirements are clear, we add the name, we pull from master, we create a branch, start working on it. So then you work on it, and then once your feature's done and you've tested it, you go to QA review. So before you move something to QA review, you should make sure the requirements are complete. You pull from master, you push up to your branch, create a pull request, and, you know, wait for someone to merge that pull request or to like approve it. Because what might happen is, you know, it's in this QA column and someone finds a bug, and then they'd say, oh, no, there's a little bug. You need to fix that bug before it moves on. So you go on, you'd fix the little bug with this ticket, move it back. And then if it was good, then the QA person would merge it to master. So yeah, before you move to master, make sure this is merged to master in GitHub. We'll talk about Heroku later. We can also even have like another Heroku tab. So Heroku is going to be your actual website, like living on the cloud on an actual server. But we're not going to do that until probably maybe Thursday or Friday. We'll talk about actually pushing stuff up to Heroku. So for now, we can just push it to this master GitHub column. And that is the one of the flows you have. This is not the only Kanban flow. You could come up with your own. But I think this one does have kind of some of the basic things that you would want. Let me select this out so you can use this as a reference. But you will all need, like every group will need a Trello board. So let me just say what you're going to need. Actually, we can go, well, okay, so this is, when we get back from lunch, we're going to put you into your groups. I actually think this is I actually think I have the groups figured out. I just want to double check with the staff, but I do think I have the groups kind of situated. But when we get back from lunch, here's the things you're going to want to get done. Hopefully by the end of today, maybe not, but let's just kind of talk about it. So here's what you're going to want to have. I'm going to throw this in Slack. So each group, you need a Trello board. You need obviously a GitHub repo. Your Lucid chart. going to create your own Slack channel. So you'll create a Slack channel that's just the members of your team. And throw both me and TA Michael in both Slack channels. And also throw Will in that as well. I think that is it for now. Cool. Any questions with that? Sweet. Cool. If that is it, let's go ahead and take lunch. I think our staff meeting might go a little longer today. So let's meet back at let's just call it 1:45. I think that should give us enough time. So for lunch, let's meet back at 1:45. The TA channel will, and then we'll break you up into your groups and you can get started on kind of getting set up for your projects. Cool. All right. Have a good lunch, everyone.
You too.